Hola a todos, my name is Ricky Pimentel, and today I'm going to talk about a new treadmill clamp protocol that looks at the cause-effect relations between propulsive force, walking speed, and the metabolic cost of walking. We all use propulsive force to push our body forward while walking. This horizontal portion of your ground reaction force largely determines your walking speed. Peak propulsive force generation during walking declines with age and also associates with a higher metabolic cost of walking. Our purpose is to study how propulsive force governs how we choose walking speed. We accomplish this using a real-time targeted feedback system and self-pacing treadmill control. Then we wondered, does metabolic cost shape the relation between propulsive force and walking speed? First, we asked participants to walk at 5 different speeds relative to their normal overground walking speed. All these trials were locked at a fixed speed for the 5-minute trial. Then we identified their peak propulsive force over the speed clamp trials and asked them to target that propulsive force while in a self-pace mode on the treadmill for another 5 minutes. Here's the relative walking speed over the full 5 minutes for all propulsive force clamp trials. You can see that the participants started off by varying their trials a fair amount, but eventually adjusted their speed relative to condition intensity. Comparing the speed during the propulsive force clamp to the speed clamp, they match quite well during the higher intensities, but tended to overshoot the lower intensities. Next, we're going to compare between clamps. The clamps match decently well for walking speed and propulsive force for the norm condition, but as we increase intensity, speed stayed about the same between the clamps, but propulsive force was lower in the propulsive force clamp. As we decrease condition intensity, speed was higher in the propulsive force clamp, but was about the same propulsive force across both clamps. Looking at the cost of transport, that changed with condition intensity, except in the negative 10% condition, as we would expect. But between the clamps, the low to norm propulsive force clamp trials had a higher cost of transport compared to the speed clamp. So in conclusion, as we increase propulsive force, walking speed also increases. And as we decrease propulsive force, walking speed also decreases. But walking speed isn't the same as propulsive force. Our participants didn't choose to walk slow at the low intensities, and they didn't choose to walk with a large propulsive force at higher intensities. And we confirmed that metabolic cost does shape the relation between speed and propulsive force, because our participants used more energy during their propulsive force clamp trial at the low to norm levels. Thanks to my lab and our research participants, and you can reach me on Twitter or on the Slack for more questions.